Ownership is a set of rules which Rust follows, and we also need to follow while writing code in Rust. So what does ownership what are the rules for the ownership? The first rule is each value should have a owner. Every value in the memory should have an owner. And the next one is there should be only one owner at a time. So for a value there should be only one owner at a time. No two owners can own that value at the same time. And the last point is if the owner goes out of scope, if the owner which is having the particular value goes out of scope, that value will be dropped from the memory. So these are the three rules which Rust follows in terms of ownership. Each value should have an owner. There should be only one owner at a time for a value. If the owner goes out of the scope, the value will be dropped from the memory. Now let's see these rules in action, and before going there, I am Chiranjeevi and this is the episode 10 of Rust series, and in this video we are going to discuss about ownership rules in Rust. And before getting into the core of the video, make sure you like, share and subscribe to this channel for the future episodes of Rust. Now let's look into the first point, which is each value should have an owner. We have already done this in code, but let's do it again for the sake of the understanding next points. So let's create a new project, cargo new, let's call this ownership. I created the project and let's go to the main.rs file and let's remove this line. The owner is nothing but a variable. I mean anything that is referring to a particular value in the memory. So let's create a variable. Let's call it let var1 of type i32, which is equal to 10. Now let's print this using placeholder and give var1. Now as expected, let's try to run this first. Cargo run, it should print 10. So every time I do the same mistake. Go to the ownership folder first and then run this. So as expected, it printed 10. Now let's try to change the value of var1. To do that, we need to have the mute keyword to the variable, and now let's change the var1 to 20, and now let's print this again. Save this and run it again. So according to the second point, which is there should be only one owner at a time, here we are changing the value, or let's do one thing, not changing the value, but let's create another variable var2 with the same value, which is 10. So according to the second point, there should be only one owner at a time to a value, but here we created two owners at a time, and let's try to print both of them at a time. So I'm just giving this thing. So we pass both var1 and var2 here. So if there should be only one owner at a time, this should give us an error that var1 and var2 are having same value, both are the owners of same thing. Let's try to run this if we get that error or not. No, we are not getting that error. We are getting 10 10. Why? Because this is not the value that we are referring in this particular point. Each value should have an owner, and there should be only one owner at a time. The value which we are referring here is not this particular value, because this value which are static types will stay in stack memory, not in the heap memory. The values which we are referring are part of the heap memory. Let's see what the difference between them. We have discussed this thing in prerequisites of programming video. when every data that we use in a program, from variables to constants to any strings, any type of data that we are using in a program, are stored inside memory. Memory is main memory, which is RAM. So in the memory there are two ways in which the memory is stored. The first one is stack and the next one is heap. So the stack looks like a pile of some books or plates, so values are stored like this, and the heap looks like a tree which is ordered in a specific way. So this is how heap looks like. We have two ways in which we order memory, we order values in the memory. So which values will go into the stack and which values will go into the heap? The values with static type will go to stack. Values with dynamic type will go into heap. What is a static type and a dynamic type? As we have discussed before, a static type is something which has a fixed size. If we see in this code, we have i32 and i32 as data types. i32, we know for sure that it will take 32 bits. So we know before compiling that it takes 32 bits in the memory. But let's say if we take a string can be of this long, or it can be of this long, or it can be of this long. Each will take different sizes. The smaller string will take smaller size and the bigger string will take bigger size. We don't know how much size it's going to take when we are compiling. So these come under dynamic types, and anything that we know before compiling the size of it, it comes under static type. So we took i32 in the example, which is of static type, so it will go into the stack. But the values which we are discussing above are the dynamic type values. You might argue that we are creating another variable, so this 10 is different value, this 10 is different value, both are not pointing to the same thing. Okay, let's try to assign this var2 to var1. So sorry, we are assigning var1 to var2. So now they should be referring to the same value. Let's try to run this. Sorry, let's try to run this again. We are getting the output without any error. So assigning values like this when it comes to static types doesn't make any difference. Now let's do one thing. Let's use a dynamic type. Like let's use a string itself. Let's call it str1. And how do we create strings? Using this string from, and let's give any string. This is fine. So let's call it from here str1, and let's create another variable str2, and let's assign it str1. Now if we try to print both str1 and str2, the variables of type i32 didn't give any error when we do the same thing, but the type strings, they give error. See, it's saying value borrowed hereafter move. What it's saying is we have assigned this particular string to str2, and now str1 doesn't have this string anymore, but it borrowed it here again, so it's giving error. That is what this thing says, this point. There should be only one owner at a time. When the ownership is shifted to str2 for this particular string, str is not owner at a time, and it is not referencing to this particular string anymore. So that's what the second point means. So why did this happen? Let's go to the memory level and examine why did this happen. When you create a variable 10 with the name var1, so what it will do is it will create this thing. So its name is var1 and it has value 10. Its type is i32, like this. It will have this data. When we did var2 equal to var1, it will create another thing of this sort. It will create another thing and what it will do is its name is var2 and its value is 10 and its type is i32. This is what happened when we did var2 equal to var1. Both are there, both are existing. But what happens when it comes to the strings is this is in stack. This is in stack. When we created a string with any string in the heap memory, I mean when we created that in our code, what happens is that any string is created in the heap. Let's say this is in the heap, but the reference to this will still be in the stack, otherwise we can't access it. So the reference to that will be inside the stack only. So its name is str1 and it says that it's type of string, and what it will do is it will give that it won't have the value here, it will have reference to this particular address. Let's say this is at the address of some yz, so this will have that yz, and it will have another thing which is the length of it. Let's say it has now 6 plus 4 10 length, so it will have this same thing. So this is what happens when we create a dynamic type. Now when we did str2 equal to str1, what happened is it created str2, it is also string, and its length will become 10 as well, but the reference is now, it doesn't copy this entire address like this same thing, it will point to the same thing, but this reference will be there no more. This is what happens when we try to assign a value of a dynamic type to another variable. This is what happens here. The value exactly copied to the other thing, but here the reference is being copied, so the previous reference will be get cancelled. This is what we call as deep copy, because we are copying everything from type to the value, but here we call it as shallow copy, because we are not exactly copying everything, we just created some other instance which is referencing to the same value. But according to Rust ownership rules, that if we have a reference to a particular value from one variable, the other variable will no more have the reference to the same value. This shallow copy of variables happens in almost all programming languages. Both the variables will keep referencing to the same object in the heap, but the reference won't be cancelled from the first variable in other programming languages. But ownership rules in Rust will do this, cancelling the reference from the previous variable if we shift the reference to some other variable. So what happens to this particular thing? This is in the stack memory and it is not referencing to any value right now. This is like free. So what happens is in most programming languages, if this happens, there will be something called garbage collector. So Go and Java has this garbage collector. So what it will do is, if any memory like this is there in the memory, and it will go there and it will free that memory so that it can be used for something else in the future of the program. This garbage collection happens in some intervals. We can set that interval in some programming languages by altering the config of that garbage collector, but this happens in programming languages like C++. We have to do this manually using function free. So we have to have this variable and pointer, and we have to give that into the free function and it will free that memory. We have to do this manually, otherwise it will introduce some bugs in the code. But Rust doesn't have any garbage collector. It will do everything on its own. When we shift that reference to this particular, when we did str2 equal to str1, at this point it will call a function drop on str1. So what it will do is it will drop this particular memory and it will be freed, and that particular memory can be used for something else in the program. Now the question is, can we do this deep copy in dynamic variables as well. So which means like if I have any string like this and str1 is pointing to this, and if I do str2 equal to str1, this should not be cancelled, but instead str2 should be created and it should be pointing to some other any string. So when we print both str1 and str2, it should print any string any string. Is this possible? Yes, it is possible, and let's see how we can do that. Let's remove this line, this print, and what we can do is, instead of assigning just like this, we can do clone. So clone is a function available on every dynamic variable, and we can do dot clone. And now if we save this and if we run cargo run, this won't give any error and it prints any string any string. That is because we haven't keep referencing to the same any string. The any string which is inside str2 is different to the any string which is inside str1. So it is not referencing to the same thing. That's why the reference of str1 is not cancelled, and both of them are referencing to difference any string. That's why we are able to access both of them at the same point. Now the only thing that is left is the last point in the ownership rules, which is if the owner goes out of scope, that value will be dropped from the memory. We have seen that in this case without clone, when we try to assign str1 to str2, the str1 has gone out of scope. I mean, that's how Rust decides the scope. In general, in any other programming language, we think that if we create the variable here, it is available inside this function after it is created anywhere. But it goes out of scope whenever we try to reassign the value to some other variable. So that's how it works. Let's do one thing. Let's create this variable str1, and what we think is after it's created in this function, it is available everywhere so that we can use it. Let's try to create another function which is return length, which will take a string as input and it will produce, let's see what it will produce, but without, I'm not giving any return type right now, but we will do that. What it will do is it will return the length of the string which it takes. So we can use length len function on strings, which will give the length of that string. So this length of string will return of type usize. This will return type usize. So this is the function. Now let's try to use this function in let length equal to, let's use this function return len, and let's pass our str1 to this function to see the length of str1. And now let's try to print this length. So let's save this and let's run this. So it should print the length of the str1, which is 10. Let's see that, and it printed 10, which is expected. Now after this line, let's try to print our str1 as well. Let's just print and see what str1 looks like, and this will give you error. That is because the str1 is passed to return length function, and now this s variable, the local variable of this function s, will have the reference to this str1, which is any string. This is similar to what we did in the previous example, which is str2 equal to str1. When we did str2 equal to str1, the entire reference is copied to the str2, and str1 doesn't have reference to the any string anymore. This is what exactly happening here as well. Now the s have the reference to any string, and str1 doesn't have reference to any string anymore. That's why it will give error. So what we can do in this case is, while returning the length of this, we can also return the string as well. We can return the string and along with its length. So now the return type will become a string comma usize. This is what we call as tuple. Remember in the data types video, we discussed about tuples in complex data types. So this is tuple which is having a string and its length of type string and usize. So when we are calling this return length function, we will get two items, which is the string itself and the length. So we can take this string back to the str1. So now the str1 will have the any string reference again, and the length will have the length. Now if we save this and if we try to run this, what it's saying is, here we are writing s, so s won't be here anymore and you can't access s dot length here. So for that, what we can do is, we can return s dot length first and then return s later. So the return type will become usize comma string, and we can reverse this as well. Now save this and run this. It should be comma, not dot. So now it printed any string again. Try to read errors as much as possible. Don't panic when you see an error, because that teaches you a lot about a programming language. So now we got this reference back to str1 by returning it from the function. So this is a bit hectic whenever we are passing it to a function and returning it from the function again. This is a bit hectic when we are in a very big flow of a very big project. So for that, we have something called referencing, and we will see that in the next video. That's it for this video, and don't forget to like, share and subscribe for the future episodes of Rush series. And in the next video, we will discuss about referencing and how it will reduce the hectic task of returning it back from the functions where we passed it. So stay tuned for that video. Until then, bye bye.